So here's problem number 57 from the chapter review assignment. All right, and we have a piecewise function, and we're asked some questions about its differentiability and its continuity. Let's remark first of all that a function can only be differentiable where it exists and where it's continuous at the very least. So in terms of where is it differentiable, well, it certainly can be differentiable on the interval from -1 to 0, and from 0 to 4. And let's just double check whether it is indeed differentiable at 0. If I were to look at the slope of the function as we approach 0 from the left-hand side, in other words, what is the limit as x approaches 0 from the left-hand side of the slope function, I think it's pretty clear that that slope is 2. If I ask the same question, what is the limit as x approaches 0 from the positive side of the slope function, looking here, we see that that slope is 1, and since those two, the two-sided limits don't agree, we can see that it's not differentiable at 0. Next question is, can we find out whether it's continuous at 0? Well, let's see. Well, I asked the same question here. What is the limit as x approaches 0 from the negative side of our function? Now, when we approach this negative side, we're going to end up, when we approach it on the negative side, we end up with -3. When we approach it on from the positive direction, we end up also getting -3. Okay? And since both of those limits are equal to each other, I would say that it's going to be continuous at 0. So I say that it's continuous on the interval from -1 all the way to 4. Of course, where the function is not defined, it's not continuous. Neither continuous nor differentiable. Well, that would be every place else outside this boundary, and that's going to be from -infinity to -1, and that union from 4 to positive infinity. Or in other ways to say it, everywhere except from -1 to +4.